I was a student engineer with General Motors. And then I got promoted as a young engineer, to reporting directly to the president of General Motors as one of the selected students to train the management training. And then one of my assignments was to try to help keep America clean, and that was by collecting scrap tires along the highways and things, and then how to dispose of them. And one was to burn them. And from that, I saw that it created such a smoke and a byproduct. We wanted to try to do something with the ash in the material. Then we tried to use it as a blend with the concrete and things. And then that advanced to perhaps using it as a filler for the highways. And that's when we started seeing that there were some properties that were of interest into other products that would do that. So in 1995, they wanted to make a clean America great again before Trump. But so that was General Motors, or the automotive industry, because there was the legislation coming back that they would be responsible for their end product. And this, as we advanced, had got to be how do you recycle or to claim these materials. One of the materials was how to recycle the rest of the car. They got involved with that. So we could see that we could blend this ash or the byproducts into other materials such as plastics or non-functional fillers. But then as we went through, we saw that there was indeed a possibility to use the filler as a filler for plastics and perhaps maybe some off-spec rubber, or in the highways, in the streets, and the supplement to the tar. So that was an ongoing project that picked up momentum because it had such a potential for recycling a lot of waste and solid waste material. So that was in 1990s. And then we went from that to getting involved with doing more pyrolysis research, which had potential with General Motors. They had their General Motors Tech Center. So that was, and then we found out that with the automobile consortium and all the research facilities of General Motors, that we could do a lot of things with the filler. And that was the start of the using pyrolysis as perhaps a viable option to solid waste problems. I had the honor of being involved with the U.S. Car Association, and I was the only independent engineer there that was not affiliated with any companies. The companies then were Goodyear and Goodrich, which is now Michelin, and Ford, Chrysler, and General Motors. So, and then we had Cooper Standard was also part of it. So that was a closed group of advanced technology participation sharing. And then we got some financing from some third parties to carry forward at the encouragement of this consortium to go forward with the testing and approval of voltage steps. And that's where you saw the presentation of the products that were made for the automotive industry by Cooper Standard. And that's the story of that. And that unfortunately got involved with some very management type or financial promoters, and the promise of all that technology that was, how would I say it? Well, was scammed by these investors. That's all, and that has been like a broken record from then until now. So without the without the without the promotional abilities of of, uh, of a financial or promoter to gain take advantage of of their potential, they took the money and ran always before you could do this before the year was up. And I think you'll see the same thing happening. It's a stuck record now because greed is the most dangerous thing going. And and the story of pyrolysis and the potential to save the world with pyrolysis is a very opportunistic way to raise money. And once you raise the money, they run. It's fun. And the last big program they raised about $100 million. We got into the Panama Papers scandal, and they get so much money in their pocket, it doesn't go to the completion of the project. That's enough for them. So they made enough money. And that's unfortunately what's going to happen. So you need to have a real strong management team that you can trust and can get involved with it. Oh, for that particular thing, the ability to upgrade the pyro char and also the off gases. So being able to, I guess, design the pyrolysis system so you can economically upgrade the byproducts, including the off gases and the oil, and then the most important, the pyro char into viable, usable commodities. But raising the money with the story and with a good conscience is my I guess, strong and soft characteristics. So that's about. So if you see what all the other rubber engineers are doing with the char, it's all as a result of what I contributed to this technology. Message is good luck. is I think the other thing is that there are so many people now that got involved in the recycled carbon black industry that they're in competition with each other. And that is just trying to prove how much smarter they are than the other people. They ought to bury their pride and get together and form their own consortium and make this a viable product that they can all participate in the profits of the whole thing. So they can share this technology. That's what I wanted to do with the ASTM thing, is to make it so that you have a standard where the products can be ordered confidently on the open market between each other. So they hit the same standard. That's where the ASTM standard comes in. That's what I was doing with this. Now I had the nomenclature was CBP, carbon black pyrolysis. But when the other competitors that put it, I wasn't competing with anybody, but they looked at it, came in order to try to change the terminology from CBP, which is going to be an ASTM standard, to RCB. That's the history of our. Just so they didn't want to use CBP. Okay, so I said, all right, go ahead and do that. That's just so because for the good of the industry and the other competitions, so they can do that. So I would say that you should not make ASTM standards so dependent on carbon black terminology. Develop your own standard for ASTM, where you can, where it can still be, you can order a product where you know will be the same, and that's a results-oriented ASTM standard. And that's what I proposed. And if you see some of that was when I was the chairman of the ASTM committee for asphalt, and that was to upgrade asphalt because actually the asphalt industry didn't want to use crumb rubber. It was too difficult to, and by using the pyro char filler to a certain standard, they could use that comfortably into asphalt. And that was by developing a standard, performance standard for the char, and that is for the carbon or the recovered carbon black. And that's what, so results oriented means that you can mix it in a particular compound and you get that kind of reinforcing, or these kind of rubber properties. Or you can, so then you can classify these rubber products, properties into different grades. So you have a reinforcing grade or a semi-reinforcing and a high reinforcing grade. But you can, it's easy for the customer to approve or disapprove or to test what kind of product they're getting. And that's all that they want. Does this perform according to that property, or does it perform to that property? Not going into a big chemical lab where you can't, no manufacturer can afford doing that. What they can afford is to test the end product. And you can do that. So every rubber manufacturer, if they want to, if you send in either a pelletized, which I don't like because I think it's what you want to do is test the pelletized product into rubber. So you might as well test a fluffy carbon black into rubber too. But you know that you're producing that particular blend that performs that way into the rubber. So forget about all these preliminary tests and get to the end result. And that's what the customer wants, manufacturer or user. Yes, that's the end result. And that's what people are looking for. Right. When I did into this general standing or what I do is look at the volatile content. So you don't want to have too much oil mixed with the so you can put a limit on that because that's going to affect the end product, and also the particle size content. After you've established a limit on the amount of volatiles in the char, you can do that, and you can also go to the particle size. And then, but you're going to have so you're going to have technologies that produce that end result. Now that's up to to the ability of the manufacturer. That tests their engineering skills or their proprietary or their competitive status. So, but they all have to produce the end product that you can do that. That's why pelletizing is a difficult thing because it just to that that's a byproduct of the carbon black industry. Because how else are they going to ship and stuff? But this is not what the recycling industry is like because you already have the product. But pelletizing is that you take something just so you can have it dispersed into rubber at the same time. So why not take the fluffy carbon black, put it into a master batch, and you have everything, all these answers at the same time. You can test the product before it leaves your manufacturing facility, and the customer can also easily test it when it gets there without going through all this other. So it's the end result that they're after, right? So supply that to the customer. So what I did was that we would mix this or blend this into a master batch at the lab, which can go straight from the grinding or pulverizing station to a anti-aeration phase, which is about a day of getting it to come to a more of a dense product. Put that into a master batch, and you can take it away, and the customer can test what he's getting immediately. So you sort that into production days or codes, numbers, and you're back at the way that people are used to supplying products. I don't need any celebration. But the point of it is, I guess the most important is to be humble about the whole damn thing and just try to get the job done and sit back and say, been there and done. That's all. It's a matter of personal satisfaction, not to brag about who the hell you are. I've spent enough time in the army to have no bitter. Yeah, I'm a spectator now, more or less. But so there hasn't been much that I didn't have the honor or the chance to take advantage of, or take advantage to work with some very smart people, and that was these were engineers from before Michelin. I remember going to the Paris Auto Show and seeing the 3 Michelin tires sitting up, and it said Garnier avec Michelin, and I looked in my book to find out what Garnier means, and the wind. So of course, but we designed tires at that time for racing and every kind of agricultural tire that you can have. And that's by pre-testing the material in rubber before it's put back into rubber by the customer. And then you verify that. I verified everything with the tag. And every engineer that worked on it, he had to be responsible for that particular manufacturing batch. I guess some of the things would be some of the markets that doesn't require high performance rubber, such as maybe for roofing materials. So that's a big market. And other materials such as some molded products that are benign and don't require a lot of things. That's a big market. Instead of trying to prove that you can you can supply the entire industry and things. That goes with time. If you can start proving and you can make a product over a period of time consistently, and the tire manufacturers will feel more comfortable in going through the expense of approving a new product. That is a very, very big concern with both the potential customer and I think you'll see that probably getting approval by a tire manufacturer. One thing is having them to test it, but the other thing is to have them approve it. That's going to take a year of consistent production, at least I would think. That's when I was chief engineer for Technical, and that was about 2,500 engineers at the time. All the same thing. You can't break that threshold without proving it. You can do something consistently the second time. That was what when I was a young engineer, they said, "Yeah, it's great, Phaser. Now do it again." We got to the point where first of all, you got to decide which is kind of accepted, is that you need a continuous process just so that you can, for consistency and for volume. And to do that is normally with an auger or with a rotary kiln. You can use semi-pyrolysis with the rotary kiln. That's what we did before. But it's one of the secret was that when you do a lab test, you normally do it in a batch type kiln. And that has the magic thing of being quiet. You don't do it. Or if you do it, you do it in a very slow rotating kiln. And then if you do it in a rotating, that kind of a lab thing, which happens that way, is that don't agitate the char. So I got into what I decided would be a quiet bed rotary kiln. That means you don't stir up the char inside the rotary kiln. To do that, you change the rotary, I'm telling you a trade secret now. You do the rotary kiln without any paddles in it. So the product just slides down the rotary kiln to what I call the quiet bed rotary kiln. Otherwise, you stir up half of the char or the good particles go up in the gas stream, in the pyro gas. That's not where you want it. You want to capture that. So you have a quiet bed rotary kiln. So the product just slides down the slope of the rotary kiln. But at the same time, you can take advantage of the gradient and the conductive qualities of a rotary kiln. And then, so we got a very high yield for the material balance of the char. Otherwise, you have half of your char goes up in the stack in your gas in your liquid product. So you get a sludge. I originally worked with Smithers Lab, and I got a very good reception from them. But at that time, they were the only rubber lab that was really acknowledged. And they didn't have enough time to continue. They wanted to end up marketing the byproduct because they got good results, and that was a long time ago. But so then the only other lab that was happening at that time were people that left Firestone, and they got the equipment from Firestone, and that was Akron Rubber Lab. That was Bob Samples, and he was the president there. And Bob Samples and Mac Wilbur. So I went to Akron Rubber Labs by popular demand because even Smithers knew he couldn't follow up with that. And Akron Rubber Labs didn't have much work to do except for, because these were all retired people or fired people from Firestone and Goodyear and everything. So that's the history of Akron Rubber Labs. So they were very, very supportive in doing that. And the other marketing company was Polymer Valley, and that president unfortunately died too. So Bob Samples and Mike Beck and Bill Klingensmith, these are all people that were influential and encouraging to go forward with the product. But presently, I don't have any people. The people that were hired by other pyrolysis companies to take my place or had a better seniority at Monsanto and other things, but they do nothing about actually approving a new product. You walk around trying to figure out how they can patent something that's not the objective. I don't know, I'd say think about the end result and not trying to prove how much smarter you are than somebody else in there. Every place competing for the top of that mountain thing, and that's not so important. Just walk up the mountain together, and that's all. That's what they can do, and they can share this. Same thing as what happened when the automobile industry tried to enter the point of then they can choose what they know the best. But at this level, I think they can get together and agree upon what you're working on is a good end result product spec. And so you're in a very good position to kind of help each other gain that position. I think that you'll probably even get into competition about what ASTM spec to use, and that's not healthy. But